Hello YouTubers. Today I said I was going to do a video on the processes I've been working on. So what I've been doing is taking graphite and trying to make it into graphene. Now your typical graphite flake has got many layers of carbon in it. You know, and whatever, it's a bunch of them, right? So what we're doing with the intercalation process that I've been doing, I've been using sulfuric acid and nitric acid. This is like a 96%, and this is quite a bit higher. Well, no, not higher, but it's concentrated. It's probably I would say 70 to 90%. I don't have an actual percentage on that particular bottle, but I know it's up there. Now what that does is that the sulfuric acid by itself will go in between each of these layers. And what the nitric acid does is, even though this is propagating in between the layers and expanding out that flake, it literally shoves, because this will just go around the outside and just infuse the outside with the sulfuric acid all over the place, right? Well, the nitric acid takes those molecules of sulfuric acid and drives them further into the flake. And that causes the entire flake to expand. You know what we have to do after you get done, and that's usually 24 to 48 hours. You let that sit, you stir it every once in a while with a glass rod, and allow the flake to do that. Now you want to use a fairly large flake graphite so that you can get expansion out of it. If you're using a very small flake graphite, the sulfuric acid won't stay intercalated. It'll just come off when you rinse it out in your water. After the 48 hours, you take your graphite product that you've intercalated and you take a beaker of water, H2O, and you basically fill this up with water, you know, 3/4 of the way full of water, and then you dump your acid graphite mix into the water, and you wash it. And you let that settle out. All the graphite particles will settle to the bottom. You pour off this solution here. And then you do it again. And you do this, and this is called washing. Washing the acid out of the product. Now, it obviously is not going to come out from between those flakes. The sulfuric acid is well bedded into your large flake graphite. But after you've done this washing process about 4 or 5 times, you can dry it out. You're going to take the dry product, this stuff here, it won't be dry, it'll be moist. Your moist graphite. And then you're going to throw it in like a toaster oven or anything where you don't. That's why I bought myself a toaster oven. They don't cost very much, $20 to $50 roughly. and I don't have to worry about destroying anything else in the house. And you take that and you throw it, and you spread it evenly on a little sheet, or like I use this glass container you guys have seen in other videos, where I just throw it in there, spread it out as evenly as I possibly can, and then bake it for an hour or so to get the rest of the moisture off of it. Now once that's done, once you've done cooked it, you'll have about the same weight graphite. It should be slightly heavier because now you have the sulfuric acid embedded in the graphite, but it will have expanded. That by itself will have expanded the graphite. Now you take your graphite, sulfuric acid embedded in it, and you throw that in a microwave. Needs to be well ventilated. Well ventilated. I have a fan right above my microwave. I open my window up, I turn it on, I open up the garage, and I microwave. And all that fumes and stuff goes right out the window. Ventilation hood, better yet. You know, if you have a ventilation hood to do it in, that's the best way to go about it. I'm eventually going to make my own, and it'll work fine, but what I got, it's working just fine. I just stay away from the fumes, because this will fume. This process will fume, and the fumes, if you breathe enough of them, will cause serious nerve damage and can eventually kill you if you breathe enough of it in. So yeah, you want to be on a ventilated hood. You want to make sure this is well ventilated when you go to do this part of the process. And then that will probably 100 to 200 time fold expansion, maybe even further. I'm not sure. I don't know the math on it. I know it's massive expansion. You'll go from a little itty bitty amount to a pretty good sized chunk. I mean, if you took about this much, it would be like this by the time it was done. So I mean, that's a fairly large expansion. And then that is the science behind the intercalation and the microwave process. Now, you can take that expanded stuff from the microwave that you just got done expanding, and there is several processes after that you can do to it. It's already going to have a higher conductivity, because what happens is those flakes that we were looking at that are all smashed together like this, they're going to come out looking like this. And some of them are going to still be connected. Some of them are going to be blown apart. But yeah, you're going to have expanded graphite, but it's all going to be wrinkled and it's not going to be flat. Yes, you're going to have higher conductivity, but it's not really good for very much of anything. I mean, other than the fact that when you mix other chemicals and stuff into it, I'm going to be using it for batteries and things, so I need high surface area. So that part of the process doesn't faze me. It doesn't bother me at all, because the more surface area you have that's touching the chemicals, the faster the electron can get from one point to the other point. But if I was doing circuits, I'd want flatter, not like that. Now, what was I saying? Oh yeah. Now those pieces that are still kind of stuck together, there's a couple different ways you can separate them, because it's not going to be completely, fine graphene at this point. You can take hydrogen peroxide, 34% solution, your H2O2, 34%, and you can throw your graphene in there, and it will separate these. these will come apart. It will force them apart. You put too much in there, and the graphite will actually get in its way. So you just put some in and keep adding a little bit until you got a kind of a dark solution. You don't want to overdo it. Yeah, you can do it, but you got to make sure. I have like I did it the other way. I had a stir rod, so I spun it, and it just kept flaking off to a certain point. And then after I did it for, I don't know, about 3 days a piece. I did this method for about 3 days per solution. Now, that's still not going to get it clear down all the way. That's going to get it closer. You're going to get down pretty fine at that point, but you're still not going to be as fine as you can possibly get it. Now, I have an ultrasonic. This is the other method you can use. You don't have to use this method. I just prefer to use this method. Before I even do the H2O2, I throw it in my blender and break up the large chunks down to smaller chunks so that the H2O2 can work more efficiently with the graphene, or the graphite. But I'll take this, probably, now that I've went through that process, and I'm going to take a sample, because I don't want to use all my product, because right now it's at the stage that I can experiment with and I don't have to do anything extra to it. But I want to see if I can increase it. If you take acetone and water, it's about 75% and 25% of this, and you make a solution, and you make that, and then you put your graphite in there. If you do a little research, you can find the exact weights and measurements, but this is the proportions. You're going to do 75% of that, 25% of that, and that would be your liquid solution, and you throw your graphite in. And then you can start straight from graphite. You don't even have to go through that other process to get a graphene solution. It just takes longer. You're going to get a very, 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 very fine graphene. You're probably not going to get as much, and it's probably not going to be very high quality. But if you go through the other steps like I've done, and then do this, your graphene quality will be a lot higher. I'm going to take this solution here, and I'm going to throw it in an ultrasonic. Now, I think I might do a couple different samples. I might do one for 4 hours, and then we'll do one for 6 hours, one for 8, and one for 12, and then measure the resistivities between all 3 samples to see which one I'm going to get the best results out of. And I'll post that, but I won't tell you the weights that I'm using. Reason being is I believe that if you're not doing your research and trying to learn this, then you're not really learning this. You're just copying, and copying is not an actual method of learning. It can help, but I mean, I am learning a lot of this stuff from Robert Murray Smith. He's not in contact, but I go and I watch his videos, and I'll rewatch them, trying to find stuff that I missed, because sometimes my experiments don't come out quite right. So I'll go through and I'll rewatch stuff, I'll write stuff down, I'll try different things, and I'm learning constantly. Now, I've put a lot of different steps together to do this entire process. I don't think I've seen an entire point A to point B end on the videos. I have seen like his transparent conductor with the sanding. I've done a video on that. I'm going to go back to that eventually, but right now this is where my focus is at. So that's what I'm working on. But they'll show you like the acetone water. They'll show you that. There's actually an electrolysis process. I've actually done that. I don't think I've done a video on it. I'll have to recheck, but I don't believe I've done a video on that. That one takes with the electrodes I was using. it would take me almost a full day to get that process to work. Now, I could have used the graph oil in it, but I wanted a very large amount, and I figured an electrode would work better because I could just keep doing it. Yeah, I get finer graphite out of it. That's okay. Anyways, this is what I'm going to be doing. This is the science behind it, and thank you.